Okay, so we're going to talk a little bit about string security and how passwords are being validated, or really changing the password is being validated. The convention is that a user, when attempting to change his password, he has to type in his previous password, his current password, and then 2 times repeating the new password. So we have to have several validations in check, right? We have to have one, is the current password correct? That's the first check, the one that he typed in. Now, if that fails, already, like, he's being kicked out of the process and he has to redo, right? Because already there we have a security check, and then he's not allowed to change his password. So if that passes, though, then we have to check that the passwords provided, the 2 passwords provided, are identical, right? That's the next check. Again, if that fails, he's being kicked out. And then we have to check the other requirements that the password has to have, such as minimum length and minimum amount of special characters, such as numbers and uppercase, lowercase, all that stuff. Also, special characters such as question marks, exclamation points. There are certain requirements where that's all necessary. So let's look at an example of the code here in. Wait, that's the wrong project. Let's look at how this is done through SpringSecurity. So, another check would be, of course, if the user is logged in, because he can only change his password. So we're not talking about a password reset. We're just talking about changing the existing password. So for that, he should also be logged in. So that's another check, right? If he's not logged in, we can kick him out as well, out of the process. So here's first we fetch the current user. And then we have this check where if data is missing from the form. So we know required data is, of course, the entire password data object, which contains the old password and 2 times the new password. So new password and repeat password are the terms that I used in this query. And if any of these are missing, we can pretty much already kick him out, right? Because he's not logged in, or he didn't provide the data that he was supposed to provide completely. So then he's being kicked out of the process. And then we check if the password is correct. And the way to do that is through the password encoder of SpringSecurity. So this is a SpringSecurity class that can be, or a service really, that can be injected into any service, any controller, any domain. Just like the SpringSecurity service is injected, and this is called the password encoder. And the password encoder has a method. It has multiple methods, but one method is password valid. And in this method, we pass in the hash of the current user password, right? Because we don't persist ever the passwords of the users in the database. We always only persist hashes of those passwords. So we cannot just compare the current user password with the password that's being provided in the post data. This can't just be compared with an equals or something like that. So in order to do that, we have to have this method that in the first parameter expects this hash. And then what it does is it takes, internally what it does, it takes this password that's been provided, this string of the password, and then it passes that password into a validation method that encodes the password to the same hash, just like it does on registration. Because if you register 2, 3, 4, 5 users with the same password, they all end up having the same hash in the database. And that's what's relevant here, is this step that's being done, where a password that's just a string of letters is being used and being transformed into a hash. If that process is the same for the same character sequence always, which in this case it is, SpringSecurity always does the same process for the character sequence in each password, then the resulting hash is the same, and then it can compare the hashes. So really what this is doing internally, it compares this hash, so this string of a hashed password, with this string, but this is internally being passed through the hashing method. And then really they are just compared. Is this hash equal to this hash, right? But so this is processed internally to also be the password hash, and then they're compared. And the result then is a Boolean of this method, is password valid, and then you can just handle this and respond accordingly, give the user some information about it, etc. Of course, next step, as we talked about, is comparing new password and repeat password. That's just as simple as comparing. And then we have, in this case, just a size check, a simple size check. So it has to be above 6. That's really it. You could, in this case, also see if it contains certain characters. If certain characters are missing, you give the error message that the password isn't secure enough. It requires numbers to be added or digits or whatever, right? So that's, you can add all kinds of validation. But in my book, it is those 4 then that are completely necessary. So those 4 are a minimum requirement to changing the password. And then everything above that, everything else is just sugar on top, really. But once everything checks and the user isn't returned out and he isn't like kicked out of the process, all you have to do really is set the new password to the password string that was provided, save the user, and on saving this user, the password is being hashed, and that hash is being persisted into the database. We can see this by going into the user domain, because there is the encode password in the before insert and before update. So the before insert, before update is being called before the domain is persisted or before the data is persisted in the database. And at each time it calls the encode password, which it takes the password provided, and it encodes it through the SpringSecurity encoded password. First it checks if the password encoder is available, but it always is in our applications. But if it's available, it encodes the password, and otherwise it saves the password in clear text. But of course, that we should never ever encounter this issue. This is just a fail-safe in case the password provider shouldn't be available. So and then the user is persisted, and you're done, and you can respond to the user back, and tell the browser that the post request was accepted. Okay, any questions? Let me pause first. So I've just been made aware that there are some projects where in the user Groovy, this part of the code is actually being commented out. So this is bad practice. It shouldn't be done. But if it ever happens this way, that doesn't have to mean that the passwords are saved in clear text either. So let's just go into that project quickly and let's look what's going on there. Because I'm most certain that it's being encoded elsewhere then in that case. So let's look at the user Groovy and double check that the password encoding is not there. So let's see. Here it is, right? Here it is. So the encode password is being commented out, and it's not being called either. We have here the before insert, before update, and they're all commented out. So nothing is doing the encoding in the user Groovy. But I want to have faith in this application and believe that it's being done elsewhere. So let's check. And I'm pretty sure that it's being done, all over the place, and mostly in these cases where it's about like, so here in the vendor Groovy, it's still, so that's important. The Groovy of another user that extends the user Groovy. Let's open that one up when it opens. See, that one still has the before insert and before update, and it also, it extends user, right? So basically, any user of type vendor still has that functionality. And maybe they're more like it. Let's just check it out. Maybe there are other types of Groovy. So the person Groovy, this is something else. This is the template. So vendor Groovy, we just saw that. And then user Groovy, it's commented out. Okay, but we have it in very many places, mostly like registration controller, which makes sense. When a user is registering, it's being done. And I gotta say here that this feels a little bit clunky, that this is being done all over the place, instead of in the user Groovy. But I remember faintly that there was a reason for it, and the reason was that if the admin was editing users, we built the user form in such a way that the password was constantly being posted with the updates of the user. So in the JSON that was sent to the user, to the backend to save the user, just to update his information, just the first name or something, in that JSON, the password was included with the hash. So the password was constantly being oversaved with the hash of the password, which was rehashed, so the password constantly changed, basically, and the users couldn't log in anymore. And of course, now we know that the easiest way to fix that is just not include the password in the posting of the form. right? That's the easiest way to do it. But we didn't think of it then, apparently, or there was some problem with it. So that's why we decided to comment it out completely in the user Groovy, and then commenting that out resulted in us having to put it manually all over the place, right? So that's why we encounter this method being called, I don't know, how many results do we have? 32 places. So really, if you encounter a situation like this, you might have to see that if you have to implement something like this, it's implemented in the right place, in the right method, etc., right? So this has to be implemented. But other than that, the resetting of the password should stay the same, except for one single difference, right? We do all the checks, just like we talked about. We do all the checks. We save the password onto the user, but then instead of saving it in clear text and assuming that the user Groovy takes the load and does it for us, we then have to include this piece of code instead. So our assignment in this case, where in the user Groovy it's commented out, would be something like this. Like so, right? So instead of the top line, we would have to write it like so, if we are in a project where passwords are encoded manually all over the place. So then that would be the way to go about it. All right.